Today we'll see the fundamental trigonometric identities. First, what is an identity? An identity is an equation that contains one or more variables and is valid for all replacement values, that means for all different angles, for which both sides of the equation are defined. The fundamental or basic trigonometric identities can be divided into several groups. First, we'll see the reciprocal identities, and this one includes the cotangent times the reciprocal, that is the tangent, equals 1. This one is an identity because it doesn't matter the value of the angle. If both angles are the same, all the time the cotangent times the reciprocal, that is the tangent, is going to give us 1. Therefore, if we isolate the cotangent, we'll get that the cotangent is the same as 1 and the tangent passes dividing. That's why the cotangent equals 1 over the tangent of alpha. This is the first reciprocal identity. The next one is the secant times the reciprocal, that is the cosine of the angle, equals 1. Therefore, if we isolate the secant, then the cosine passes dividing and the secant is the same as 1 over the cosine of the angle. And the next reciprocal identity is the cosecant of the angle times the sine, that is the reciprocal of the cosecant, equals 1. Therefore, the cosecant equals 1 over the sine of the angle. These one are the reciprocal identities. Now, let's see the quotient identities. The tangent of the angle is the same as y, that is the opposite, over x, that is the adjacent. If we remember the unitary circumference, we have the adjacent side, that is x, the opposite side, that is y, we have our angle, and we have the hypotenuse, that is the radius of the circumference. Then the sine of the angle is the same as the opposite over the hypotenuse. The sine is the opposite. The opposite of my angle is the same as y over the hypotenuse, that is the same as 1. That's why the sine of the angle is the same as y. And the cosine of the angle is the same as the adjacent side, that is x, over the hypotenuse. The adjacent is the same as the value of x, and the hypotenuse is the same as 1. Then the cosine of the angle is the same as x. If we understand this, we can see that the tangent of the angle is the same as y, that is the same as sine. The sine of the angle is the same as the opposite side, that is y, over x, that is the same as the cosine of the angle, that is the same as x. And the cotangent of the angle, that's why this is called a quotient identity, because it's a division, is the same as x, that is the same as the cosine of the angle, over y, that is the sine of the angle. That's why when we pass x is the same as the cosine, that is our adjacent side, over y, that is the same as the sine, or the opposite side. And the Pythagorean identities are sine square of the angle plus cosine square of the angle equals 1. Here we need to remember also the Pythagoras theorem. The Pythagoras theorem tells us that the y square, that is the opposite side to the square, plus the adjacent side, that is x to the square, is the same as the hypotenuse. In this case, is hypotenuse to the square, that is the same as 1. And the sine of our angle, again, is the opposite, that is 1 over the hypotenuse, so the sine of the angle is the same as y, and the cosine of the angle is the same as our adjacent side over the hypotenuse. The adjacent side is x, and the hypotenuse is 1. That's why the cosine is the same as the value of x. When we isolate and we use the Pythagoras theorem, we have that the value of y is the same as the value of the sine. But y to the second power is the same as sine to the second power of the angle, plus the value of x to the square is the same as the cosine, but to the second power, because we have x to the second power, and this equals the same as the value of 1. That's why this is called the Pythagorean identities. That is, sine to the square plus cosine to the square of the angle is the same as 1. Another Pythagorean identity is tangent square of the angle plus 1 equals secant square. We can do exactly the same, and we can check that this identity is true for all angles. And the next identity, Pythagorean identity, is cotangent to the square of the angle plus 1 equals cosecant square of the angle. Now, no standard method for solving identity exists, but there are some general rules or strategies that can be followed to help guide the process. First, we need to try to simplify the more complicated side of the identity until it's identical to the second side of the identity. The second step is we should try to express both sides of the identity in terms of only sines and cosines, and then try to make both sides identical. Number 3, it's important to try to apply the Pythagorean identities as much as possible. Number 4, it's important to try to use the factoring and combining of terms and multiplying one side of the identity by an expression that is equal to 1, squaring both sides of the identity, and other algebraic techniques to manipulate expressions. Now, let's see an example. Let's verify the next identity. We have the cosine of the angle plus sine of the angle times tangent of the angle is the same as the secant of the angle. This is the identity that we want to verify. First of all, we need to see which one is the more complicated side, the left side or the right side. As we can see, the more complicated side that we need to check is the left side. So we're going to change this side, and we're going to try to check that all of this is the same as the secant. Then we need to change all to sines and cosines. So we need to change this tangent as a sine or cosines. As we can remember, the tangent, we can use the identity that is the same as sine over cosine. So the tangent is the same as the sine over the cosine of the angle using the quotient identity. So we change tangent using my identity of quotient over using sine over cosine, and then here we need to manipulate. So the sine times the sine we multiply is going to be sine squared over cosine. So we try to simplify this, and then we need to get that we will have a 1 on the denominator. So the least common denominator is going to be cosine of the angle. Cosine over 1 is going to be cosine. Multiplied by cosine, we got cosine squared. And if we have cosine over cosine, will give us 1 times sine squared is going to give us sine squared. So simplifying this, we have that cosine squared plus sine squared over cosine of the angle is the same as secant of the angle. Here we use the algebraic manipulation. Now we need to remember that cosine squared of an angle plus sine squared of an angle is an identity, and this is the same as 1. This is our Pythagorean identity. So we simplify cosine squared plus sine squared the same as 1 using the Pythagorean identity, and remembering that 1 over the cosine is the same as the reciprocal of the secant. So 1 over cosine is the same as the secant. So we can verify that secant, that is 1 over cosine, that is the reciprocal, is the same as the secant using the reciprocal identity. Now, let's verify the next identity. The sine of y plus the sine of y times the cotangent square of y equals the cosecant of y. Now, I'll give you a few minutes and we'll check our results. Thank you.